Jai Hind everyone. My name is MILI Srivastava and I am going to today I am going to discuss about NIST Cloud Computing Reference Architecture. So first of all, what is NIST Cloud Computing Reference Architecture? The NIST Cloud Computing Reference Architecture features on the requirements of what cloud service provide, not how to design solutions and implementation. The reference architecture is intended to facilitate the understanding of the operational in cloud computing. The cloud reference architecture, that is CRA, serve as a collection of design guidance and design patterns to support a structured approach, that is to deploy services and applications in the cloud services and applications in the cloud computing. This means that every workload is deployed with security, generate and compliance in mind from day one. So, this is the introduction of NIST Cloud Computing Reference Architecture. Now, a template description of the architecture probably defined at different levels of abstraction. Highly abstract, showing different functionalities, lower level show methods performing specific tasks. Vendor neutral description that does not stifle innovation, by definition a specific technical solution. A conceptual model for discussing the technical requirements and operations of cloud computing. So, as we already discussed, the NIST Cloud Computing Reference Architecture focuses on the requirements of what type of cloud services provided by the cloud providers, not how to design solutions and implementation that are various levels of in cloud computing. The reference of this architecture is intended to facilitate the understanding of the operational in the cloud computing. A blueprint to guide developers in the design of cloud services and applications. Compositions of interconnected services, implementations, reusable logic for building applications, list of functions and their interfaces, that is APIs, description of their interaction. A cloud infrastructure may be operated as public, private, community or hybrid cloud. As we already discussed about public, private, community and hybrid cloud. These are the service deployment model of cloud computing, that is in public cloud computing deployment in public type of deployment model of cloud computing. We know very well that same infrastructure used by many users over the public network. So, this is less secure. Public deployment model is less secure other the comparison of private and community. Next, private, exclusively access to specific end user, hosted on user's premises, on-site installation or by hosting company. Basically, public cloud computing deployment model used by developers, that is highly secured and expensive also in comparison of public cloud computing. Next is community, access to group of users with similar concerns, like so many developers use this community cloud services along with the same broadcast network, that is community cloud computing deployment model, highly secure than public, and in comparison of private this is less secure. Next is hybrid. Combined offering. Hybrid is a combination of public cloud and private cloud. The cloud reference, in these terms, the cloud reference architecture server as a collection of basically this is a collection of design guidance and design pattern to support a structured approach to deploy services and applications in the cloud computing model. This means that every workload is deployed with security generated and compliance in mind from day one. So, basically we studied in this part actors and roles and architectural component. There are so many actors in cloud computing reference architecture, like consumer, broker, consumer, auditor. There are so many actors and their roles we discussed earlier. So, what are actors and roles? core individuals or users with key responsibilities in system function. All the actors have specific functions in their according to their role. Architectural components. What are architectural components? For managing and providing cloud services for deployment, orchestration, management, security and privacy. Individuals or organization with key roles. First is consumer. What are the consumers? Those who ever use the services of cloud computing known as consumers. These services are provided by the cloud providers. So, consumers acquires and uses services like us. We are using cloud services by the cloud services provided by the cloud provider. So, we are known as consumer. These services are of different types, as we already discussed, like infrastructure as a service, communication as a community as a service, platform as a service and application as a service. There are so many cloud services provided by many companies in today's market, like AWS, Amazon, Azure, Google Cloud. So many cloud companies, they can provide cloud computing services. Next is provider. As we discussed earlier, they pour over of services. They can whoever provide cloud services known as cloud providers. For example, AWS, Amazon Web Services, Cloud, Google Cloud, IBM Cloud, Alibaba. There are so many services which are deploying in cloud services. Next is broker. Broker is basically works as an intermediate between consumer and provider. What kind of services consumer demands, in this terms broker helps to consumers and provide that services to consumer. So, intermediate between consumer and provider. They hide complexity of services or create new services. Next is auditor. Independent performance, security, monitoring and assessment of cloud services. Next is carrier. Carrier provides connectivity and transport of data and services between providers and consumers. They behave as a transport, as a connectivity between consumer and provider. This is NIST reference architecture. With the help of this diagram, we can easily understand this is cloud carrier, this is cloud consumer, cloud auditor, cloud providers. They can provide different types of services like software as a service, platform as a service and infrastructure as a service. Cloud service management, in this part of feature, this includes business support, provisioning, configuration, portability and interportability. Next, this is a security layer and this is a privacy layer. What kind of service provided by the cloud provider? Software as a service. Software as a service example, for this service we can take example of Gmail. Gmail is a software and we can only access that service with the help of cloud provider. Many cloud providers, this is software as a service. Gmail is a software and we only take services of Gmail. We can't do anything less or more in Gmail. There are some accessibility criteria like 15 GB, 20 GB, and after that we can enhance our productivity, enhance our scalability according to our use. This is software as a service. Next is platform as a service. Platform as a service basically used by developers. Infrastructure as a service. Infrastructure as a service deployed by virtual machines. Whenever there is so many hardware, we have some hardware quantity, then we convert that hardware into virtual machine for better utilization of hardware, memory and operating system. So, by this provider infrastructure, virtual infrastructure provide by the cloud provider, and we can access that service with the help of some nominal amount given to the cloud provider, cloud service. Now, what is cloud consumer? Browses the service catalog of the provider. request services depending on activities, uses, scenarios. Sets up service contracts with the provides. Consumers need SLAs to specify their performance requirements to be fulfilled by the provider. However, SLAs are offered by cloud producers and in most cases are not negotiable. This is cloud consumer. Basically, consumers are those who can access the service of cloud which are provided by the cloud providers. So, may be billed for the service, software as a service. Consumer may be billed based on the number of user, time of use, net bandwidth, storage, volume. As I already give you the example of Gmail software. In the case of Gmail software, we can see that a particular storage, we can use a particular storage, we can use a particular amount of that service. After that, we need to provide our scalability for that service. That is software as a service. Consumer may be billed based on number of users, time and use. However, what are the bandwidth, storage, volume, all these things are differentiate with the user to user, consumer to consumer. They are different. In case of some users, they use simple storage volume, they use 15 GB, 20 GB, etc. But in the case of high level companies, they can use memory in TB, MB, high amount of storage. So, they can scale up their scalability and they process that amount, their scalability according to their requirement, and they can access that services. Next, infrastructure as a service and platform as a service. Consumer may be billed according to processing, storage, network resources, number of virtual machines, HTTP calls, number of IP used, net bandwidth and storage volume. So, how we can connect these services from NIST cloud computing architecture. The cloud reference architecture, that is CRA server, as a collection of design guidance and design patterns to support a structured approach to deploy services and applications in the cloud. This means that every workload is deployed with security generated and compliances from day to day use according to their requirement. So, contracts that are negotiated and agreed between provider and customers, so to locate, reserve resources to satisfy consumers' requirement with efficiency and optimal resource and service uses. To guarantee and agreed SLA, that is service level agreements, the auditor must be capable of measuring and monitoring relevant metrics. Example, service availability, network metrics, storage metrics. Different SLA models must be considered for infrastructure as a service, platform as a service and software as a service, as each model sets different requirements. SLAs can be defined clearly for IaaS. For platform as a service and software as a service, SLAs, that is service level agreements, are still vague and difficult to be defined, as these refer to higher levels of functionality but can be agreed between providers, customers based on applications, requirements, business cases and business level plan. So, these are the contents of service level architectures. Business level objectives. What are the roles and responsibilities, requirements, operational policies, continuity, limitations, financial, glossary of terms. Service level objectives, these are the business level objectives. Whenever we start a business, so what are the responsibilities? These are the content of that responsibilities, that is roles and responsibilities, requirement, operational policies, continuity, limitations, financial, glossary of terms. And in the case of service level objective, the resources, performance indicators, service deployment, service management, description, security and privacy. In this case, we are most effective part. There are most effective and essential part, that is security and privacy, or that is highly required in infrastructure as a service or private community. So basically, there are some parameters along with their descriptions. CPU capacity. What is CPU capacity? CPU, how much CPU exhales their virtual machines, that is CPU speed. What are the CPU speed? How they can run multiple programs at a time. This is CPU capacity, CPU speed for virtual machine. Next is memory size, cache memory size for virtual machine. Boot time, it is also required very less time of MB to be ready for use. Storage size of data for short or long term of contract. Scale up, maximum of virtual machines for one user. So when we create virtual machine from our hardware, when they can easily scale up or scale down according to their requirement. They can scale up or down their services according to their requirement easily. So this is the this part of flexible scale up or scale down terms is highly should be very much flexible. So, so can user access that service very easy manner, in very easy manner. So, scale up, maximum of virtual machines for one user. Scale down, whenever we are not required that much of memory, that much of service, we can easily scale down our service. Minimum number of virtual machines for one user. Scale up time, time to increase a specific number of virtual machines. Scale down time, time to decrease a specific number of virtual machines. Auto scaling, Boolean value for auto scaling feature. Maximum number can be configured on physical server. Maximum number of virtual machines that can be run on individual server. Availability, uptime of service in specific time. What are the response time? Time to complete and receive the process. This is an example of cloud services. We can say that this is cloud computing architecture. This is cloud computing architecture. These are the servers, laptops, phones, tablets, desktop. We can access that service of cloud computing from anywhere, anytime. So this is infrastructure as a layer. This layer is called infrastructure as a layer, which is created by virtually and with the help of some optimal hardwares. We can easily create some virtual environment that is called infrastructure as a service. Next is platform as a service. Platform as a service basically used by developers and the application as a service. Acquires cloud provider. So what are the cloud provider? First of all, I am going to discuss what are cloud provider, what are cloud consumer. Cloud consumer like us, they can use the service of cloud services, and those who are provide that services known as cloud provider. So acquires and manages the computing infrastructure, runs the cloud software, makes services available to interested parties, makes arrangements, contracts with consumers, may also list SLAs, that is promises to consumers, or limitations and obligations that consumers must accept. Providers' pricing policies and SLA are not negotiable most cases. So what are the responsibilities of cloud provider? This is cloud provider. Basically, these are the responsibilities of cloud provider. The first is service deployment and service orchestration, cloud services management, security and privacy. So, main part of cloud, the main responsibility of cloud providers to provide a specific service that are required by user, that service, and they highly secure the service security and privacy. In the case of private network, private cloud computing model, security and privacy plays very important and useful role in cloud computing services. So, what are the scope of control? Application layer. End user apps and services used by software as a service consumers, installed, managed by platform as a service consumers and software as a service providers. Middleware layer, VM layer, virtual machine layer, provides building blocks for app development libraries, DBMS, Java, virtual machines used by platform as a service consumers, installed, maintained, managed by platform as a service providers, hidden from software as a service consumer. So, this is the scope of control. So, basically in NIST computing reference architecture, that is I already told you that with the help of all these layers and all these infrastructure, this is basically focuses on the requirement of what cloud services provide, not how to design. They are not worried about how to design that services and what are the solution and what are the implementation levels of these services, intended to facilitate the understanding of the operationals in different kinds of cloud computing model. Next is operating system layer. What are the role of operating system layer? Operating system virtual machines and drivers hidden from software as a service and platform as a service consumers, controlled by infrastructure as a service providers, used by infrastructure as a service consumers, and IaaS provider may allow multiple operating systems as virtual machine. Whenever virtual machine manager and virtual machine requirement both are installed directly installed in operating system, so then we can call it as the operating system layer. Next is platform as a service. The provider manages infrastructure and provides tools of deployment of applications. The consumer has control over the applications but limited, no access the infrastructure. Example: operating system, servers, storage, drivers, etc. Next is software as a service. Consumers have only limited administrative control of the application and services. Software, example of software as a service, there are so many services which are already defined or implemented. Our role is very less in that type of services. Our control, we can say our control is very less in that type of services. They can set up as a software, they can set as a software, and they allowed us we can use that service, not modified. We cannot modify that operating system, middleware, so many things. Next is infrastructure as a service. The provider acquires physical resources, servers, networks, storage, and runs the software to make these available to infrastructure as a service, platform as a service consumer through virtual machines. Consumers have to control over virtual software components, operating system, network. Provider and consumer share the control of resources in a cloud model. The cloud reference architecture serves as a collection of design guidance and design pattern to support a structural approach to deploy services and applications in the cloud computing model role. So, this means that every workload is deployed with security, governance and compliances. So, a provider and consumer share the control of resources in a cloud. Provider and consumer share the control of resources in a cloud in this manner. This is operating system layer, this is middleware layer, and this is application layer. Cloud providers, they are basically provide three types of services, as I already discussed in my previous lecture. This is infrastructure as a service, the platform as a service, and this is software as a service. And cloud consumers, what are the cloud consumers? They access the service of cloud given by cloud providers, that is software as a service, platform as a service, and infrastructure as a service. Next, performs independent. What are the cloud auditor? Cloud auditor audits the cloud services provided by the cloud provider. They audit the whatever they promised to the user. They provide that services in lenient pay or not. They audit that systems. So, what are the cloud auditor? Platform independent examination of cloud service controls and express opinion, issues evaluation, ideally have a contractual clause enabling third parties to access cloud operations to determine the extent to which cloud operations are implemented, executed as planned and agreed. So, basically, auditor's objective, what are the basic objective of auditor is to verify, conforms to standards or to security privacy controls, performance confirmations to SLAs, etc. Issue security privacy performance audit. So, basically cloud auditor audits the what are the issues controlled by the security, privacy and performance. So, they all these things, and basically three things, security, privacy and performance, these three things are audited by cloud auditors. Cloud auditors plays as examine of cloud providers, whatever they provide services, all the services are promised as promised or not, all the services are required to reach the user, required are suitable or not for the they can highly ensure the security, privacy, performance, what are the performance of that services which are provided by the cloud provider. Basically, these things is audited by the cloud auditor. Now, next is cloud broker. What is cloud broker? Cloud broker basically works as an intermediate between cloud consumer and cloud provider. So, integration of cloud services by consumers can be too complex and can be requested from a cloud broker rather than from a provider directly. An entity service operated by the provider or third party provides services in three forms, basically intermediation, aggregation and arbitrage. So, what is cloud broker? Cloud broker basically works as an intermediate between cloud consumer and cloud provider. So, provide services in three forms. The first is intermediation. What are the intermediation? Presents the service to consumer, example in catalog, provides, enhance, improves a given service, example by adding identity, management, performance, reporting, enhance, security, etc. So, this is the basic term of intermediation in one of the services they can provide by the cloud provider. The second thing is aggregation. What is aggregation? Aggregation combines and integrates multiple services into one and another. So, in this reference architectures, all these are designed basically a guideline or guidance and design pattern to support a structured approach to deploy services and applications in cloud computing. Next is arbitrage. What is arbitrage? The services being aggregated may change or come from different providers. So, there are so many cloud providers, those who are provided the services of cloud services. So, they can also audit the services, whatever the services required. This is arbitrage. Next is example user scenario for broker. We can see by this diagram, this is cloud consumer and this is cloud broker. and this is cloud provider 1 and cloud provider 2. Cloud consumer gives to the cloud broker to their requirement, what are the requirement of consumer, and they offers two services, cloud provider 1 and cloud provider 2. They offers two services. Cloud broker enhance two services to cloud consumer, and whatever the service is more required, more suitable for this consumer, they can arbitrate that service, they can achieve that service with the help of cloud broker. So in this model of cloud computing, the cloud reference architecture server as a collection of design guidance and design pattern to support structured approach to deploy services and application in the cloud computing. This means that every workload, this types of workload is also deployed with the security, governance, different parts. This type of workload depends and we can say distribute in different parts. Next, what are the what kind of interaction between actors? So what are the actors? This is cloud consumer, this is cloud auditor, cloud broker, and cloud provider, and this is cloud carrier. What is cloud carrier? Cloud carrier works as a transmit or transport in cloud auditor and cloud provider. So what are cloud consumer? Who can access the service of cloud computing, known as cloud consumer. What are cloud broker? Cloud broker, whosoever provides the service of cloud computing, this is cloud broker. What are the cloud auditor? Cloud auditor audits the services given by the cloud broker, and this is cloud provider. So this is the example of the communication plan between a cloud computer and the cloud consumer. The communication plans for a cloud auditor and called auditing information, and the communication path for a cloud broker to provide services to a cloud consumer. Next is cloud carrier. What is cloud carrier? Cloud carrier basically acts as an intermediary that provides connectivity. Cloud carrier, in this diagram we can easily say saw that this is cloud carrier, this is cloud carrier, and this is this acts as a path between cloud provider and cloud auditor. So cloud carrier acts as an intermediary that provides connectivity and transport of cloud services between cloud consumers and cloud providers, provides access to consumers through a public-private network or telecom provider. A provider may set up SLAs with cloud carriers in order to provide services with the level of SLAs offered to consumers, that is, they required dedicated or secure connections. Next is architectural component. So what are the architectural components? Architectural components for managing and providing cloud services describe the important aspects of architectural system: service deployment, orchestration, management, security, and privacy. Portability and interportability issues for data and services are also crucial factors, as consumers need confidence and moving data and services across clouds. Security and privacy build trust and acceptance in cloud ability to provide a trustworthy and reliable system. Business support implementation of specific businesses models. So what is service orchestration? Composition of service components to support cloud providers activities. In provider activities, service layer, in we already discussed about services layer like infrastructure as a service, platform as a service, and software as a service. Resource abstraction, cloud control layer, interfaces for accessing virtualized resources, example hypervisors, virtual machines, and virtual stores. Physical resource layer, interfaces for accessing to physical resources computer, disk, router, firewalls, etc. This is service orchestration diagram. This is facility, this is hardware layer, this is physical resource layer, resources, abstractions and control layer. This layer is called as a control layer. This layer is basically this is a service layer, infrastructure layer, as a service, platform as a service and software as a service. So, in between service layer and physical resource layer, there is a resource abstraction and control layer. This layer control by the level, by the interaction between service layer and the hardware layer. So, software as a service, what is the software as a service? Introduction: software as a service, sometimes referred to as on-demand service. Software and its associated data are hosted centrally, typically the internet, cloud, and are typically accessed by users using a thin client, normally using a web browser over the internet. These are the software as a services examples: equivalent applications that are installed in business computer networks or personal computers, accounting, collaborations, consumers relationship management, enterprise resource planning, human resource management, content and content management, etc. Next is platform as a layer. Platform as a service is the delivery of computing platform and solution stack as a service, facilitates deployment of applications without the cost and complexity of buying and managing the underlying hardware and software. Platform as a service offering may include facilities for applications design, application development, testing, deployment and hosting, as well as application services used as team collaboration, web services integration and marshalling, databases integration, security, scalability, storage, persistence, state and developer community facilitations. These services may be provisioned as an integrated solution over the web. What are the examples? So, platform as a service: services to develop, test, deploy, host and maintain applications in the same integrated development environment. Web-based user interface creation tools, multi-tenant architecture, integration within web services and databases, support for development team collaboration. What is infrastructure as a service? The logical computational resources, data, software accessible via a computer network rather than from a local computer. Users or clients can perform a task such as word processing with a client such as browser and with service provided through such cloud-based computational resources. Any computer connected to the internet is connected to the same pool of computing power, applications and files. User can store and access personal files such as music, pictures, videos and games or do word processing or on a remote server. No physical carrying storage medium. So, this is the deployment models: public cloud, community cloud, hybrid cloud and hybrid IT delivery. This is model of infrastructure as a service, the intercloud and the cloud storage. The intercloud is an interconnected global cloud of clouds and an extension of the internet network or networks. Cloud storage: network computer data storage where data is stored on multiple virtual servers, is generally hosted by third parties rather than being hosted on dedicated servers. What are the basically issued phases in infrastructure as a service? This is privacy, compliance, legal open resource, security, availability and performance, data uses, sustainability and sitting use by hackers. This is service management task. This business support can be described from different perspectives: provisioning and configuration, portability and interportability. This is cloud service management model. This is business support, provisioning and portability or interportability. Next is management business support, business related services. Customer management. In management business support, this is customer management, contract management, pricing, accounting and billing. This is report and auditing. Rapid provisioning, resource changing, metering, SLA management. This is privacy issues. Basically, user habits, personal data uses mainly are responsibility of cloud providers. Security also a part of cloud providers. This is considers impact per service model. This is virtualized or dependent on basic different types of services, whatever we required by cloud consumer. This is NIST security architecture, and I already explained all the terms of NIST security architecture. Thank you so much.